Okay, so if you're not familiar with GoToWebinar, then that arrow on the orange arrow on the top will close that panel so that you don't see it throughout and you can see the full screen. You can do the communication or voice through either audio, through computer, or through phone. So that's those two options are for you to choose. You're obviously muted during this webinar so that we can go through the information. But of course, if you have questions, there is a chat area or question area that says type message here. So if you've got anything that you want to ask, please do so through that panel. And at the end, time permitting, JP will go through your questions, and or maybe throughout we'll try and address them so that we make sure that we're addressing whatever you want. So I think that's about it for that section. With that, I'm going to introduce JP. JP's been with SOLIDWORKS for a couple years. He comes from a full electrical background. He was in the Navy for US, and you will see some of these things. I won't take his punch away from him or his pictures away from what he's going to tell you, but he's probably the person that I know who's been around the world the most. And he'll show you how he's done that and with one of the technologies in the world that fascinates me the most, which is submarines. And you'll get to see his story. So I'll come back at the end to close this off and let JP take you through streamlining your electrical design with us. All right, go ahead, JP.
Thank you, Joelle. Well, thank you everybody for joining me here today. Before I even jump into who I am and show you some cool pictures, I do have a quick poll because while we start, usually that's when most people are attentive. So I'm going to go ahead and jump into our first poll, which is, what are you using now? Is there a specific tool that you're currently using? I was trying to be a wise guy, and I put that last comment in there. We are so good that we don't even need to use schematics. And I can see a couple of people already trying to pick that answer. But for the most part, a lot of people are still using things like Visio, and I've seen a few people use Microsoft Paint to get their job done, or even simple as pen and paper. So DX Designer is another one I see coming in right now. So I'm going to give it another 10 seconds here, and I will close it out, and we can capture that. All right. So we got about almost half the people using AutoCAD, AutoCAD LT, AutoCAD Electrical, but AutoCAD in general. But thank you for your input on that, and I will try to correlate a lot of what we do to the audience that we have here. So with that said, my name is JP Emanuel, as Joelle said. I actually live in the Northeast of the United States. I know we have plenty of people from the East Coast, maybe a few from down south, quite a few from our friends up north. But what brought me to Connecticut, because I actually grew up on Long Island, was before that I was in the military, as Joelle said. And I served aboard the USS Alexandria, and this is us actually north of pretty much everybody here, up in the North Pole. And from there, I became a defense contractor, and I did a lot of one-off designs, a lot of R&D work, where I started with a white paper design, an idea, and we ran with it, and it took off. And as you can see from here, these are pretty intricate pieces of equipment that are still, I believe they are. It's been a few years since I've been with the Defense Department, but still some projects that we were working on, they're still active. So they're pretty pictures. Unfortunately, I can't tell you what they do. I always like to start off with a quick icebreaker. I love this image here. This is what I picture is going on, and no offense if there's any mechanical engineers listening to the call right now, but this is what I picture is going on in a mechanical engineer's head when they are talking to an electrical engineer and they are talking about the electrical side of things. A lot of times, maybe there is a big solder blob, which we've all maybe experienced there, and some holy water, but I just find this pretty amusing when you're dealing with a schematic. So the typical design process that I see, that I'm guilty of too, is we draw things out, whether it's in something like Visio or even AutoCAD. And we don't use any of the intelligence built into those tools because, quite frankly, a lot of times they don't have it. And then from there, we have to document everything we did in that schematic somewhere separate, like Excel. We're all comfortable with Excel, at least I hope we all are. And we capture our bill of materials on our 2-from wireless. And then from there, we have to go in and we have to audit that. Or we have to second check our design and make sure we've ordered all the right parts, if we've got all the right components and everything is set up the right way. Well, that process is the vicious cycle where it doesn't really ever end. I've been involved with projects where I get to that audit phase and I'm auditing it, and guess what? The next project is knocking on the door and we're ready to start the next one. So this process needs to be streamlined a little bit better. And that's where SOLIDWORKS Electrical comes in, where it takes a lot of that back-end information, that reporting and that auditing and that design, we call them design rule checks, and brings it up front while you're doing your design. So you're going to hear me say this a number of times: garbage in, garbage out, where the more information you put up front while you're doing your design, the better reports and the better auditing you will capture later on. So that you don't have to sit in front of Excel for a week to make sure that you've ordered all the right pins for your connectors. So the key factor, the main meat and potatoes behind SOLIDWORKS Electrical, is our manufacturer parts library, the shared library. And what this is a way to essentially collaborate with multiple sheets within the electrical environment, but also the mechanical side. And what I mean by that is, with this one particular connector here, this keyed connector, I can have several different ways to represent that connector digitally, with a line diagram, detailed schematic symbol, a 3D part, and even a 2D footprint, and a few other items that we can get into a little later. But you can see here, there's a lot of information. This is all the metadata about this particular part. And there's actually quite a few more fields that we can add to this if we absolutely need to, depending on what industry you're in. So this is a quick document that one of my counterparts made here. We have this power supply symbol here on the page, right? Well, there's a lot of information about this one particular item right on our schematic sheet, including numbers that are not actually on the page right here. We cropped them out. But also in our reports, there's a lot of different representations of something just as simple as the part number. So all these different types of reports, if you have to generate these manually, there's a lot of room for error. And actually, the guy who actually built this slide, he actually did make an error on it. Unknowingly, he made an error. He just fat-fingered it, and he put the wrong number in. Now, in retrospect, it's probably not a big deal, but that could have been on a label and then put on a wire or a cable somewhere in an assembly somewhere, and that could have caused huge problems downstream. So what this product does is help alleviate a lot of that pain. So what I'm really going to dive into over the next 40 minutes or so is SOLIDWORKS Electrical and how we can use it with our mechanical side, because a lot of people are interested in SOLIDWORKS Electrical because of the 3D capabilities, and that's what we're really going to get to at some point here in the near future. So first, we're going to start off in the schematic side and talk about the communication and collaboration between the two sides, and then we're going to go ahead and we're going to route some wires, we're going to route some cables, and we're going to route a harness, a very simple harness right now, and then we're going to take that harness and we're going to turn it into a drawing. And then we're going to go in, and if I have enough time, I want to do this because this is one of my favorite new little collaborative pieces between electrical and mechanical, and we're going to work with some smart components and actually capture the correct information back over on the electrical side after we're done routing. All right. So with that said, I'm going to go ahead and open up my mechanical assembly. As we see here, this is the box we'll be working with so that we can have some sort of visual aid as we're moving through our design process. So when we're looking at a schematic, we don't have to use our imagination too much. We have this cabinet, everything inside the schematic will relate inside to this box. Now, we're working with this box today. One thing I will note is that even though we're working with this box, a lot of the processes and functions that we are working with today will correlate to all the different industries that are out there: medical, aerospace, automation, anything that you work with right now. These processes will, will work for your specific industry if this particular item that we're looking at does not exactly correlate to what you're doing. All right. So with that said, I'm going to jump over right here into my document tree on the mechanical side. Okay. And this document tree here is the same document tree that I have over on my electrical side that we'll see in just a minute. But the nice thing about this is that I can go ahead and open the files or open a viewer of those schematic sheets and see the progress being made to the other side on the electrical side over that cubicle wall or in that other office or even, on the other side of the country. Well, in this case here, I can see that, there's progress being made, but maybe there's a few more items that might be missing in this schematic. I also have the ability to actually open up on my other sheet. I also have the ability to embed spec sheets right into my project. So now I can go ahead and if I have a spec sheet that I want everybody to have access to, well, yes, we can keep it on our network and we have a specific folder for all our spec sheets. That's great. But if there's specific ones or maybe proprietary ones that we made ourselves, we can embed those right in the project. And now everybody who has access to that project also has access to that spec sheet. So I'm going to go ahead and we're going to jump over into SOLIDWORKS Electrical. And one of the first things that I see when I first open up SOLIDWORKS Electrical is what we call the Projects Manager. As soon as SOLIDWORKS Electrical lets me open it. By the way, a quick note, I am working in SOLIDWORKS 2020 right now. So it is a beta version. I do a lot of beta testing, so just be wary of that as we go through this. All right. So, but anything I show right now is still available in what is available to the public today. So as I said, the first thing that we see is our projects manager, and we're going to go ahead and open this project. Notice that it's in red. That means that somebody else has it open. Yes, in my case here, I have it open because I am the one working in my standalone system here, but in an actual working environment, there may be multiple users working in this project. It just gives me a heads up, lets me know that somebody else might be working on this project as well. And as you can see here, we have that same document tree available to us as we just saw over on the mechanical space. So let's jump into our different sheet types. There's a couple different kinds of sheets that we have available on the electrical side. The first one we have is what we call a line diagram or a block diagram. Excuse me. And you do not necessarily need to have images in there, but there is an ability to embed an image into that particular block diagram symbol. In this case here, what I like to personally use these line diagrams for is for more of a high-level overview of everything in my system. Maybe just a system overview of everything going on. It's a great way to show what you're designing to somebody maybe up the food chain that might not necessarily care or know about the detailed schematics that you also need to produce. So it just helps to open that communication between maybe the mechanical side or the higher ups, as well as maybe your customers. So what we're going to do here is we have our schematic, our line diagram, I should say, and I'm going to go ahead and insert a symbol. Now, when I insert a symbol, the last symbol I used happens to be the one right here, this socket module. If it's not, there's a lot of different symbols that are defaulted in the software that we can choose from. There's also filters if we want to look for certain types of filters, certain types of symbols. In this case here, I know it's this module, and now I can assign it to a new part number. But I've already got this part number in my assembly, which we'll get to later. But I'm going to go ahead and correlate it to T4, terminal 4 here. But if you notice as well, I'll redo it again here. When it first came in, it automatically made it T6. It's not going to overwrite any parts that components that I already have in my project, helping me to alleviate any pain later on where I might have not ordered enough or over ordered too many parts going forward. So I'm going to go ahead and correlate this to T4, and just like that, it now has the information. Oh, I'll put it out here so we can see that. And if absolutely necessary, I can always move these around, as we can see here. So the next thing I want to do, very simply, I'm going to go ahead and connect this up. And just like that, I now have T4 in my line diagram. But let's take this a step further. I want to go ahead and now add the detail between my power supply and this socket module, because there is a Molex connector here, and there's a lot of different pins that are actually inside of this. So let's go ahead and open up one of our schematics. And in this case here, we could see that I'm missing that same symbol, or the T4. But instead of going back through my symbol library, every engineer's favorite feature, Control-C, Control-V, is still available in SOLIDWORKS Electrical, and I can very, very easily go ahead and just drop that right in and copy it right in. And if you notice, as I said before, it did not overwrite the existing any existing parts. It added T6. In order to change that, very simple. I'm going to go ahead, find T4, and if we notice, it gives me a quick little view to let me know, hey, this is T4. Do you want to connect this one and make those collaborative? And just like that, I now have T4 for that as well. So moving right along with our schematic, because I really want to get into some of the 3D and the harnessing, because a lot of people I know on the call right now would love to see more of the harnessing side of things, and we'll get to that. Well, let's go ahead and we're going to draw some wires. So wires, they're not just, in SOLIDWORKS Electrical, they're not just lines in a layer anymore. There's actually some intelligence built into all these different wire styles. And you see here, I've got a couple wires, and I can go ahead and copy paste that as well if I absolutely need to. And I'm going to go ahead and I'll do it this way instead. I'm going to go ahead and copy this exact wire and drop it right here. Now, what happens in other softwares when I take this line and I drag it over the top of another line, or I accidentally draw a line over another one? Well, usually you have something there. It's like almost like a duplicate layer, right? Well, this tool is intelligent enough to realize that those are the same wire styles, and it essentially absorbs that other piece. So I only have one wire there. If you notice, I don't have any extra, these little blue squares that let me know for the endpoints of that wire type. And the reason I'm bringing that up and the properties behind it is there's a lot of intelligence built into these wires, as I said. Of course, there's the graphical representation. It's an orange line, and I can make it dashed, and I have a formula which we'll get into later. But more importantly, when I get to the 3D side and I want to route this, I'm actually going to go ahead and route. It's going to come out as a 20 gauge orange wire. If I'm working with something like fiber, or if I'm working with something like pneumatics, I can also add bend radius in here. And that way, I won't get a bad crimp or a really bad bend on one of those items. So for this case, a 20 gauge wire has a nice bend radius. I'm going to leave it at 0 for right now. So the next thing I want to do is I'm going to go ahead and I'm going to add some arrows to these two little lines right here. Because right now they're just going off into space. There's nothing really connected to those. So what we have is this tool here called origin destination arrows. And I can go ahead and find the two sheets and place them next to each other, as we see here. And I'm going to go ahead and connect these two wires together. So select the orange wire, and if you notice, it will not let me select the black wire. Again, it's a nice little design rule check that if you've ever been involved with trying to get a schematic done extremely fast, I've been there where it's like, hey, it's Friday, we need this done by the end of the day. Oh, thanks for the heads up. And now you're just trying to draw it all out and get it out the door. Well, this here, if you have your wire styles set up, this will help alleviate that pain that 2 weeks from now, you won't find that there was something cross-connected because you were in a rush to get that schematic done, which is a nice little touch. So I'm going to go ahead and connect these up. I'll connect the other two as well. And just like that, I now have hyperlinks associated to these, and a very simple double click will take me to the opposing end. The other nice thing with this, I won't do it right now, but if I export this project to a PDF, these are also hyperlinked in the PDF. So instead of handing somebody that giant 11 by 17 book with 400 pages in it, Now they can have a ruggedized iPad in one hand and maybe their multimeter in the other hand while they're trying to ring something out in the field. It's a lot easier, a lot faster, and you're just communicating that design easier as well. So now that I've got all this information in my schematic here, well, I don't want to have to go and redraw this every single time. I have my power supply. I have my 4 Molex connectors. I have all the wires with all that information behind them, all these arrows as well. And in this particular case, this power supply, if you've ever worked with Vicor, this power supply requires this little hub, this additional component here that it needs to run to get any output power. So in the case of something like this, well, I don't want to have to redraw this every time or find that old project that I was working on, copy it from an old project and bring it in. And then I may still have to add some metadata to it. Well, with this, I can go ahead and highlight everything here. And I can simply drag it over into what we call our macros palette. I can give it a fancy name. I can put it in a specific library. And just like that, I now have this macro. Now, what is this going to do for me? Well, the next time I need it, I can simply take it and drag it in. And all the metadata, the arrows go away because there's nothing connected to it on the other side. But all the metadata within this power supply and all these Molex connectors is now built into this symbol here. This is huge because I have the power supply, which may have 1 or 2 or 5 parts. Each Molex connector is a housing and however many pins associated to it. This hub has 3 parts to it. The connector has 2 parts plus 3 pins to it. So think about that. Every time you're going to go ahead and generate a schematic, is all that part information, all that metadata is built into this part now. Now, I don't necessarily just have to have 1 symbol or 2 symbols like that. Maybe I want to include this entire piece of a circuit here if I so desire. I can have my entire input circuit, which I'm comfortable with because I know this EMI filter and I know this power supply. I'm going to use this every time. I'm going to go ahead and create a macro out of that. I can give it a good name so that way I can recognize it later on. Even more so is that it is also saved into my macros manager, which is my library, which is available to everybody that I'm working with on my network. So when I design this schematic one time and I save it as a macro, nobody else in my company should have to create this same schematic over again because it's built into the network now, and now they can just add it to their macro palette because these are personalized. You can set this up per user. They can pull that particular macro out and just drag it in, and all that metadata is built into it. So talk about saving time. It's a huge time saver, a huge tool to be able to collaborate with your teammates and just get your job done a lot faster. So from there, let's go ahead and we finished up our schematic. Let's go ahead and we're going to wire some stuff up. So back over onto the mechanical side, we have all of our different parts in here. And as the mechanical engineer, if I switch roles real quick, the mechanical engineer has already been putting all of these parts in here. He's taken the time to mate all of this stuff up. And a quick note, if you feel like your system is running a little sluggish, a good rule of thumb is once you get everything mated incorrectly, make sure you right now I have everything fixed, but if you, instead of float, I'll just do it to one of these here. So you'll see that little dash here. If you want, you can just go to fix. And then by doing that, it suppresses those mates, which makes your assembly just run a little bit faster, maybe even a lot faster, depending on how it is. It's a nice little touch. If things have to move around a lot, maybe not the best option for you, but if things are going to be staying in one spot, try to use the fix feature. It definitely helps a lot. I've noticed it helps a lot for me anyway. All right. So I'm going to go ahead and we're going to go route some wires. But before I do, I want to check that T4 that I had, which it's already associated to a part. So the mechanical engineer has come in, he's mated all this stuff up, and now everything needs to be associated. And when I say associated, all of the parts that we have on our mechanical side, on our electrical side, we can see here, this is our electrical component tree. There needs to be some correlation between the electrical side and the mechanical side, and that's where this window comes into play. So in this case here, I'm going to go ahead and disassociate it so we can reassociate it and see what it looks like. All right. So each part will have a little checkbox next to it. So in this case here, I do have the ability to insert, which means if you remember that key factor I showed before, that slide with all the manufacturer part information, well, if I select insert, it's going to go to that particular file. It's going to look to that field that I have a solid part in the directory for that field, and it's going to pull that up into my assembly here and allow me to mate it as necessary. The other option, the mechanical engineer has already mated everything up. He knows the parts. He just doesn't know which one is J1 and P1 and so on, or M1 and M2. You're just simply going to go associate. You're going to find the part you want. All the parts that are already associated with something else become transparent. I select it. I hit my enter key, and I make that association. It's very simple to make that association between the two sides. And just like that, we're done with that one association. So let's go ahead and route some wires. Now in this case here, I'm going to do a sketch route, and I'm going to select a couple components. We've been working with these socket modules the whole time, so I'm going to go ahead and route these socket modules. So while it's doing this, what it's doing right now is it's looking at the schematic, it's looking at the connection points on every single one of the symbols I have for my socket modules. It's looking at the solid part, which also has connection points built into it. I did not show that, and if you would like to see that, I can show that in a little while here. But each one of these parts has connection points built into it. So if you see there on each one of those, it's A, B, C, D, E. So every single one has a connection point correlated back to the electrical side. Well, once it figures out the wire styles that they're going to route, the properties, remember the 20 gauge wires, we showed one of them before, but each one of those wire styles has a property to it. In this case here, I routed these as sketch lines because if we were to route them in full solid route, it would take quite a bit of time to route. Now, we see here that I routed all the socket modules. That's great. It looks good. But if you notice, there's also this really random yellow, rigid-looking line that I've got everywhere in my assembly. I'll try to move slow so you don't get a headache on your end over there. But what that yellow line is what we call an EW path. This EW path is a guideline that allows us to route where we want the wires to route. Because if I don't have this in here, and I just simply, I could suppress it. I'm just going to hide it for right now. If I don't have those guidelines in there, then the wires are just going to route through any bulkhead wherever they want. They're going to still route, but you didn't tell it where to go. So there's that option where you would set up this EW path and tell the wires where to follow and what path to actually follow. There's also the ability to use segregation manager, which allows you to separate power versus comms, things like that, using those EW paths. Okay, so just a quick view, we can see here there are 4 different wire styles, the red, the yellow, the purple, and the common, the blacks here, going throughout, and they do follow that EW path that I did have set up there. So great, we routed our wires. Again, I did it as sketch lines just to save us some time. I could have routed them as a full solid. There is an option to do that. I could route all of them. If you already are using SOLIDWORKS routing features with SOLIDWORKS Electrical, I absolutely recommend you route as a sketch line first. Maybe you might have to route a couple times as a sketch line before you do a full solid route. It will save you a lot of time because a lot of times you might say, oh, I really like the way this is all set up, but I might need to tweak my EW path over here to make the wires conform to what I really want them to do. And if that's the case, you might have to reroute the wires a couple times to make a nice clean setup and then do the full solid route so you can get that really nice visual aid to help you going forward. All right, so did my wires. let's jump back over into the electrical side. So how do we create a cable? Well, cables, I'm using my, I'm going to use my air quotes, even though you can't see me, I'm using my air quotes here. I actually did do air quotes. But I'm going to go ahead and administratively take some wires and I'm going to turn them into a cable. So this is just one method. This isn't all the methods. There are other methods you can use. We can use a mixed scheme and use a single line if we absolutely need to, which more of a training thing. But these 8 wires here, most people know, or maybe not everybody knows, orange, white, green, white, blue, blue, white, green. Hey, we're dealing with an Ethernet line. Well, I want to turn this into a cable because we're not going to route 8 wires individually. So in order to do that, I can simply come in and associate cable cores. I've already set up a cable, which I'll just show you real quick. I'm going to go ahead, new cable. I can find the cable that's built into my collaborative library. So everybody's working with the same cables and everybody's working with the same manufacturer parts. And again, everybody's working with the same macros. I can go ahead and find the cable that I want to use and pull it into the project. In this case here, like I said, I've already captured it in my project. I'm going to simply associate those cable cores. And just like that, I now have a cable. Pretty straightforward. Again, you don't have to draw all 8 wires out. There are other methods that we have that allows you to draw just one symbol to show an RJ45 to another RJ45 with one connection point if you absolutely need to. But for this, I really just wanted to show you administratively how we turn that into a cable. So once we do that, again, our wires are routed here. Let's go back over into the mechanical space. And I'm going to go ahead and route some cables. So just like we did with the wires, we also have the ability to route cables. In this case here, I am going to do a full solid route. I am going to use selected components, and I'm going to do these RF cables up here, these SMAs. And the other piece of the puzzle that you need to worry about, not really worry about, but just have set, is your routing parameters. In this case here, because I'm dealing with a smaller box, I would want to set these routing parameters a little lower. If I was dealing something like a huge overall assembly, then maybe I would want to have 6 inches or 3 inches, depending on how tight that EW path and how constrained we want those wires to follow that path. That's really what these routing parameters are. So in this case here, I've selected those 4 SMAs, and I'm going to go ahead and route the cables. Again, I'm going to let the software do everything for me. If I were to use the manual routing methods with SOLIDWORKS Premium Routing, you could do it, but it's going to take you a heck of a lot longer to get it done with that method, but building the splines and everything else. This allows you to work with your schematic, correlate those parts, 2 parts in your schematic, and then automatically route those parts, those cables, I should say. So let's see here, see if I have any questions. Can I take an IDF CircuitWorks assembly and make all of the connectors live? I'd have to see what the CircuitWorks, the assembly looks like. You should be able to at least take them and we can pull it in. We might be able to take that information and import the data into SOLIDWORKS Electrical. Okay, so just like what I'm showing. You should be able to, maybe as an XML file. I'll have to double check on that for you. Use a model per ref. Yeah, we'll talk about that later, John. So as you can see here, I routed those 4 cables. So I've got my RF cables. They go to the external side of the box, right? Pretty straightforward. And let's say I don't like the way one of them is routing, or maybe I want to put it, maybe this one's just kind of floating. We want to shock and vibe on this. We want to maybe route it up through the same little fastener up here. Well, you do have the ability to edit the route. I'm not going to edit the route right now, but you do have the ability to edit that route, and you can use that spline, there are points along that spline that you can push and pull and move that wire, that cable to form whatever you want. One note about that is that you can, if you do any manual editing of the wires, the cables, or the harness, like now, like I would be doing right now, and you decide to reroute those wires, cables, or harness later on, anything you've done manually will be removed, because it's just going to ignore what you did and try to reroute it. So the best method I like is to actually edit that EW path and try to force the wire or cable to follow the bend that you want it to do. That way it's less messing around later on. All right. So now that we've done our cables, we've got a couple cables in there. There's a few more in there, but just to kind of keep it clean in here, we'll just do these 4 right now. The next thing we'll do is we will go ahead and we will route our harness. Now, back to the electrical side. I've already got one harness set up, and we're going to work with just this input circuit here. It's going to be this one connector to these 3 different connectors as well, and that's going to create our harness. Now, with that said, let's go ahead and create an additional harness. So maybe my hub and my power supply is going to be on another harness, or let's see, let's pick a different one. We can mess around here a little bit. Let's take this connector, these 4 wires, and this connector, and we'll make a harness out of it. So very simply, I'm going to go ahead and select those 3 items, and I'm going to add to harness. From here, I can create a new harness, give it a name. So again, I'm administratively taking the information that I've already got in my schematic, and I'm turning it into a harness. I'm not redrawing this information as a harness. It's already there. I'm just telling the software, hey, when you do it, now you're going to put it into this information, into this table as well. So, new harness, H2, harness 2. Add harness, done. We come back into our harnesses. We should have H2, and we have wires, and we have 2 components in there. H1, which is what we're going to route in just a minute here, we already have 3 wires and 4 connectors in there. All right. So now that we have that routed, we also have, besides the route wires button at the top, the route cables button, we have the route harness button. And in this case here, you can route all, or you can route 1. So H1 here, and this does take an extra few minutes to route a full solid harness, because it won't just do sketch lines for this. So I did go ahead and I routed this ahead of time, so we're not sitting here watching me route this. Let's see it come back. Hopefully, otherwise I'm deleting it and we can watch it. So you can see here that I've already got the harness in here, and it routed from my input power, and it came around to my breaker on-off switch there. All right, and then from there, obviously, we go back to the EMI filter, so on and so forth. So I set that up again. What was there? There was an EW path that this followed, and I set this up to kind of constraint to that. So I've got my harness set up. So now, what else do we want to do with our harness? Well, a lot of people would like to take that harness and actually, well, turn it into a drawing, right? Because I don't want to have to redraw all that. So in this case here, I'm going to go ahead and I am going to flatten this harness. So you can see here, it came out, it pulls it out as a separate assembly with the components that are attached to it. And I'm going to, in this case here, I'm going to make this segment here the center of my harness. I can also add drawing options if I so desire. In this case here, I'm going to just do an annotation view, no drawing options just yet. We'll do that in just a second. So it's going to take this, and I'm going to let the software go ahead and create a harness drawing for me. or not drawing yet. We got to get to that next. But now I have my flattened view. I have a couple lengths in here. And the other nice thing, which we'll do in just a second as well, is now I can come in here and I'm going to go ahead and create a drawing. I'm not going to add balloons. You do have the ability to add balloons. It just adds a whole bunch of extra information, graphical information right on top of this. In this case here, I'm going to just do the bill of materials, the circuit summary.
Whoever it might be to standardize custom.
And from here, we'll go ahead, move these out of the way, and we can see that small harness. It's not a big one. You can definitely get bigger than just these little connectors here. But again, it's adding the information here as necessary. The other nice thing with this, which I've really gotten used to, is I can go ahead, open that part. And if you've ever had to try to import images and stuff like that, I have the ability now to simply drag that image in. Obviously that's bigger. We'll change the size of that. Let's see here, maybe 1 by 2. There we go. So now I took the 3D part, I took the drawing file of that part, or the front view or top view of that part, and I've added that in. A lot of people like to see that, especially when there's some crazy pinout configuration. Oh, it's upside down. We can rotate that. But we can see here that I didn't have to draw that. I didn't have to sit there with my circle tool and have to draw all that information out and then add little, A, B, C, D, E, F on there if we needed to. So this is highly powerful to be able to create that. From here, now you can go ahead, as I said, you can add balloons, you can create more tables, you can export this. You also have the ability to import this drawing back over into our electrical project. And from here, you would go ahead and if you want to import it, you can. Otherwise, we're at the point now, after we routed all that information, we can come in and we can generate some reports because we want to capture the length of a lot of that information that we have. Now, within here, we have our manager, our reports manager. In this particular project, I've only got 4 reports set up, but there are a lot of other different types of reports that we can show. In this case here, I can also export them without even just going to the project. I can just export to Excel, text file, or an XML. In this case, of course, we're just going to add it to the project. And we're going to let the software, again, garbage in, garbage out. All that information that I've put into this is going to be pulled out of this project and manipulated and put in a fashion, a readable fashion for us within the project. And then from there, we can export the whole project to a PDF or to drawing files if we absolutely need to, and we're good to go. I guess there's quite a bit of information on here that it's trying to pull. So let's see here. Just another second. It gives me an opportunity to get a sip of water. All right. So we can see here that inside of our project tree, our document tree, I should say, we have all the new sheets in here. We have a list of cables. We have a list of bill of materials. And again, these are totally customizable. These are, right now, they're organized based off of, manufacturer. But if you want to separate them out based off of vendor or based off of location or function or whatever it may be, there's a million different options for you and combinations for you to choose on how you want to organize this information. It's a very generic form. I've seen some very complicated ones as well. Some of our customers have created some really cool looking reports that pull a lot of different information from a lot of different areas. So this is just one small example. And then, of course, we also have our list of wires, our to from wire list. I didn't number the wires, which is very easy to do. But you can see here that I captured length on the wires that I did route. And in this case here, we captured, well, it's set up in millimeters. So maybe up north, For those folks up north, maybe this is a good one, but maybe you want to change that to inches. Very easy to do. But you can see there that we have all those different types of reports. And again, there's a whole bunch more that we can do as well. All right, so let me jump back over to this. So one other thing that we wanted to show, I tried to get this data set to work correctly before this started. But what this is called smart components. Now, these smart components here are extremely powerful, and for lack of a better term, they are really awesome to work with, especially for things like bulkhead connectors. So if anybody out there is working with bulkhead connectors, this can be a very powerful tool for you. And the reason why we're about to show is it allows you to set these parts up. There's a YouTube video that you can watch, or actually there's quite a few YouTube videos on how to actually build this, or simply contact your local reseller and they can help guide you in the process of doing this. So what this does is it allows you to set up a sketch. And in this case here, I have a sketch associated to this SMA connector. And all I need to do is, if I move this, because it's mated right now to this plate, all I need to do is simply go ahead and rebuild this after I move these around. And the holes will follow. Now, not only will the holes follow, but if we notice down on the bottom right here, the cables also follow. So the cable information that's connected to these, the length in particular, is going to change as well. So that is extremely powerful as well. So we're going to go ahead, we'll move it one more time. We can watch as we rebuild and watch those two cables move to the new location. And of course, it will change the length. That length does have to get pushed, which you do see in the video here in just a second. It does get pushed to the other side. But again, not only do you take advantage of that, the other piece of it is that, well, my machinist needs to know where to cut these holes. Well, we can see here that those two holes in particular are not really centered perfectly, but in this case here, they're in the center. Well, now I can go ahead and live move that. And this is just standard SOLIDWORKS functionality. This isn't anything special about SOLIDWORKS electrical in particular, but in conjunction with SOLIDWORKS electrical and working with your electrical engineers, this becomes highly powerful and highly collaborative environment. And now you can see that those two circles have now moved to the outside. So that's all well and good, but now we're back over in the project for this particular that payload, that standing that stand that I just showed you, and we can see here that I have W6 and W7, and I do have W6 and W7 built into my report. I'm going to delete that report real quick just so you can see that I'm not messing around. I've got a new cable report going to generate from scratch. It's probably going to give me the exact same numbers, the same lengths as I showed before. So 4.25 and 8.84 is W6 and W7. Great. So let's go back over into the mechanical side and let's move those two SMAs around. So, yeah, sure. I guess I moved them all the way over there on the other side. Do a quick rebuild. We can watch the cables underneath. You see them move. The only other step that you need to do in order to push that information back is go through and what we call the update wire and cable length. So this is going to, because the first time you route, it's going to push it. But if you make any changes, you need to update that. And there's that tool right there that allows you to push that information back over to the electrical side. A simple update, and we can see that those reports are now updated with 10.27 and 10.87 for respectively for those W6 and W7. So with that said, we're pretty much done with the electrical side of things. I'm going to pause this so we don't get into that just yet. There's a lot of questions coming in. I'm going to get to those questions in just a second. I hope everybody's got a few extra minutes here. I know I'm getting close to the end of the hour. Let me finish out this PowerPoint and I'll jump right into those questions. So what we just saw was SOLIDWORKS Electrical. And SOLIDWORKS Electrical has a lot more features that you can take advantage of. I only have an hour to really try to give you a dive into what we deal with, and I think are some of the best features about SOLIDWORKS Electrical. The other tool that I work with is called SOLIDWORKS PCB, and that's this tool right here where I can take a circuit board and I can actually design the shape of the board in SOLIDWORKS, because a lot of times that's where my constraints come and that's where my keepouts come from and that's where certain information about my design come into play. And I can push that information back over into SOLIDWORKS PCB, which is a separate tool. And we can see here that that board shape is now available for the PCB designer to work with. So now there's less iterations going back and forth between those two sides. Hopefully that makes sense. Very quick video. I love showing it because that little piece of the connector alone is extremely powerful. So one other thing that I love to share this is, who else on my team can I share the information? We already saw here that the mechanical engineer and the electrical engineer can really start to hone in and share their information. But there's a lot of other tools out there that we can think about. Composer, for example, maybe our marketing material or technical documentation is great with Composer. Simulation, are we designing this the right way? A lot of people already know about simulation, but I love bringing it up. It's a very powerful tool. Things like MBD for machinists and stuff like that. These are all great tools, and actually there's a couple more that I haven't updated this slide in a while. There's actually a couple more tools as well that you can think about. But it's not just about the engineering team anymore. It's about marketing. It's about logistics, about field services. Everybody is involved. You're one big team, and all these tools together will help make everything better, for lack of a better term. So one last slide here is, I love to show this because a lot of people don't know it exists. We have what's called the Electrical Content Portal, the ECP for short. There are, last I looked, there are 131 million parts on this website. It's a lot of the metadata that you would need for your parts, so you don't have to rebuild your libraries. The second one here is 3D Content Central. If you're doing mechanical work, you've probably heard of it, but nobody wants to go and reinvent or redraw or re-engineer or reverse engineer parts. There's a lot of parts on here that you can take advantage of. And then thirdly, mysolidworks.com. There is a lot of powerful information on this website here. If you are on SOLIDWORKS subscription, if you're already a SOLIDWORKS customer, you do have access to I guess it's maybe Joel can mention it in a minute, is access to the higher level where you gain access to some more training and a lot more videos. But there's a lot of electrical videos on there now of like how to create a symbol, how do I edit a manufacturer part, little things like that I personally put in there because, if I'm busy during the day, I don't want to have to go and call my reseller. I want to know the answer and I want to get back to work. So there's a lot of little quick 2-minute, 3-minute videos on there so that you can go ahead and get your job done and keep moving along the way. So with that, Joel, while I look at these questions and try to organize these a little bit, I think Thomas is on the call too. I think he's capturing a lot of these, which is awesome. Do you have anything else to add, Joel? I do.
You can hear me?
Yep.
Wonderful. All right. So thanks for all that great information. I know, JP, you have stories about where, wrong lengths have been ordered because of the designs not being done. I've got stories of 400-page documents where people are spending months verifying and making sure that there's no duplicate of wires being called the same thing. And still finding errors throughout and it being very cumbersome. So we've all got stories, and you as a designer may have them as well, of things that have just gone wrong in the past in updating reports or not having the right length because of that connection to the mechanical world, whatever it may be. I'm sure that you saw something here today that can alleviate that or fix it completely. And when we say that we take you from X amount of time to do certain things like that to zero, we really mean zero, right? As JP mentioned at the beginning, a little more work up front, so it may not be completely zero, but it's still work that you need to do. upfront to label things properly or to let the tool label things properly with you, will bring you 0 errors later down the road, and that's golden, and it's huge. So I'm sure you saw something in there that's of value. JP was mentioning a library where you can access videos and different things. So that's mysolidworks.com. As a user on subscription, you have access to mysolidworks.com. You can also purchase or may have received during a purchase a mysolidworks.com professional that gives you access to more of the library and more of those videos and how-tos. So there's a lot of information there. Do check that out if you are a customer on subscription. Obviously, your best resource at this point will be your reseller, right? We've shown you one example, and that's great. And you can go see other examples. If you've seen JP do the beer manufacturing kit, then that's another one you can go see. Get some different information from there. But obviously, if you want to see how this relates to you and what you do, then we need to talk to you personally, and your reseller is going to be your first contact for that. So if you don't know who that is, then we'll help you. But if you do, they will be following up with you. Please ask them to set up a call to discover how this could impact your business and maybe work through a return on investment with you to see how that makes sense and how we do take things from X amount of hours to 0 or you know, and if you don't believe us, then put it at 50%. You'll still see the return on investment, believe me. So with that, I need to jump off, but JP, you've got some questions to answer. Those who can stick around a little past the 2 o'clock, please do so. Otherwise, JP has your contact for who asked those questions, and we can definitely get back to you individually to make sure that, that we answer those. All right. Thanks, everyone. Have a great day, and back over to you, JP.
Thank you, Joelle. One last question I see popping up here is, does SOLIDWORKS Electrical have the capability to connect to printers like Phoenix Contact or cutting machines? So this is something that this is near and dear to my heart. This is something I've personally been asking for. Unfortunately, there's no direct link. For example, I've been asking them to try to get them to hook up to like Brady printers or something like that. But maybe one of the developers are on the call and they're listening to me right now. But there is the ability to export to an Excel spreadsheet or to an XML file that you can import into a lot of those different types of machines. Does SOLIDWORKS Electrical have the intelligence to leave the heat restriction for spacing? So you can set up, if you import parts, now that depends if it's 2D or the 3D side. On the 2D side, you can add in specific metadata to add to that. You can put that in there and maybe generate a report about it. If you create a cabinet layout, which I did not show, you can space out those parts because you can add multiple parts in a cabinet layout or even in a 3D assembly. If you're working with cabinets, you can highlight several components at the same time and insert, let's say 5 of them, and insert all 5 of those at the same time. Before you click the insert button, there is an option for spacing between those. And you could set that up. Now, what I've seen a lot of customers do, especially on the 3D side, is you can go ahead and generate essentially a transparent box around a component. For example, maybe it's a power drive and it needs a certain amount of space between it, you know, actually vertically, depending on where the fans are on the model you're using. So you can set up some sort of a transparent box which can actually be colored red or green or whatever, and now you can maneuver and manipulate your cabinet and make things up correctly as necessary. With that said, it is 2 o'clock. I will leave it open for another minute or two here. If you have questions, if I don't answer your questions, then I will get back to you. There, it does allow me to keep track of all the questions being asked, and I will reach out to you directly and answer those questions for you. Otherwise, if you have questions, you can go ahead and contact your reseller, and they will definitely be able to help you going forward. So I appreciate everybody joining today. And thank you for taking the time to watch this. And hopefully, depending on where you are, it's time to go eat some lunch. So have a good day.
Hey, nice job, JP.
Thanks, Chris.